Hello, welcome back to Cracking the Cryptic and another episode of Gas. We are going to go through 5 gas days today. I want to say 5 gas puzzles, but maybe this one qualifies as more than one. But anyway, remember we were still in the period in which there was a crossover. Now I know that ends during these 5 puzzles, and I will explain about that as we go along. Don't forget, we have released this month's Patreon reward on Patreon. Quite approachable Sudoku themed on our apps. It is available to our paying patrons. Thank you so much to all of those who support the channel. We are very, very grateful, honestly. And at some point soon, we will hope to bring out the solutions to the Star Wars hunt from last month. Tricky that actually, but anyway, we will do that soon. Also on Patreon, Simon's Fistamafel riposte, if you like, to my solve of a Fistamafel puzzle. And anything else going on, you can look on the links for all our apps and merch and all that good stuff. But the first 5 links to the 5 genuinely approachable Sudoku puzzles this week, and they start with Small Samurai by Terganus. Now, this was still part of what I've now learnt was a gas gap crossover. So the normal setters of the genuinely approachable pencil puzzles swapped for 1 calendar week with the setters of the genuinely approachable Sudoku puzzles, and they did each other's puzzles. So that's why we've ended up with names like Jovial and Shy, and this one, Terganus. So the rules here, I'll go through the rules of all the puzzles, then I'm going to try and solve them on the clock. That's how I do it, trying to earn hats. 2 hats for a quick solve, 1 hat for a decent solve, and a dinosaur if you stumble to the end. Now this one is called Small Samurai. There are 5 4x4 grids. There's a green, a blue, a red, a yellow, and a white, which overlaps a little with the others and is here. And in each of them, it's just 1 to 4 in each row, column, and 2x2 region. Now, we've got a between line. Digits placed along the between line must have values between those of the ends of the line. Digits joined by a black dot have a 1 to 2 ratio. Digits joined by a white dot are consecutive. Not all dots are given. Digits along an arrow must sum to the digit in the circle, and digits along a thermo must increase from the bulb. So normal set of rules, but a bit of everything. One for each 4x4 puzzle apart from the middle one, I guess. Looking forward to that. I do like overlap puzzles. Now, next we have Slot Machine by Clover. Normal Sudoku rules apply. Each vertical strip has the same digits in the same order, but digits wrap around when they reach the bottom of the grid, and that's why they don't appear 1 in each row. But wherever 1 is, it'll be 2 cells above 2 in this row, but allowing that the grid is wrapping around between the top and the bottom. I hope you understand that. Number 3, Thermo Sudoku. For this is the classic thermo rule. Digits must increase along the thermo from the bulb. That's by Sam. Then Philip's puzzle is called Ego. Digits in grey squares must be even. I don't know if Ego is from the comics universe Philip's been using. I don't think it is, but anyway, that's what it is. And then we have an Arrow and Quads Sudoku by Clover. Digits along an arrow must sum up to the number in the circle. Now, digits in a white circle must appear somewhere in the 4 cells surrounding that circle. Note that if a digit appears twice in a white circle, and it does, I think that's the theme of this puzzle a lot, it must appear at least twice in the 4 surrounding cells. Oops, that's not the right thing. I was just trying to get in the right mode. Okay, so now on Samurai here, I am not going to have... I don't think that the app will stop the puzzle. So I'm going to also put on a stopwatch as well as restarting the puzzle just in case that does work. And then I just hope I've got it right at the end. I don't think the machine will tell me this time. But I am going to start now. Do have a go at all of these puzzles. They will all be brilliant. There's no doubt. They always are. But I'm going to start now. Let's get cracking. Okay, so I'll put the clock on as well. Now, well, I think the clues are helpful. This has got to be 2 and 3 on a line between 1 and 4. because they have to be different there. Here, look at that. These definitely, that's a 1, 2 pair, and that's a 1. They're all the minimum numbers, and 4 is the maximum, so that must be right. There must be a 1 on this pair. Oh, this is now 3, given the 4 there, and we can fill in 1, 2. So I might try and finish yellow first. We've got a 3, 4 pair, a 1, 2 pair. We can do 2, 3, 1, 4 there. And look, yellow is finished just like that. Okay, let's have a look. Maybe this has to be a 2, 4 pair, but there's an overlap cell, so that can't be the 2. Right, that doesn't help on the thermo. This is a 1, 3 pair. This can't be a 1 for the white box, so there we go. I don't think that thermo was at all necessary as far as I can see. This can't be a 3 because it's got 2 numbers bigger on the thermo. This is going to have to be a 4. This is going to have to be a 2. I think this red puzzle is going to finish very quickly now as well. 3, 1, that's a 2 for the white circle. It goes, well, I think that's obvious anyway. 2 on a black dot's always going between 1 and 4. Now that's a 3 in its white region. 1, 4 pair. That's a 2, 4 pair. And actually I'm running out of steam there. That's a 3 in the blue. Now this is 2 or 3 in the middle of bigger numbers. I might try and get those first from something else. Right, over here we've got a 1, 4 pair, a 2, 3 pair, a 1, 4 pair there. This must be 3. That's 1 or 4. Oh, this is getting stickier when I didn't expect it. Right, this can't be a 3 or a 2, so that's also 1 or 4. This must now be a 2. There we go, 3, 2. We've got to get a 3 in this region. That's 1 or 4. We're left with lots of 1 or 4 possibilities. So in the white, that's a 3. And this is a 1 or a 4, but it must be a 4. So that's going to resolve all of our 1 in 4s through the white and the green, I think. 4, 1 in the circle, 4. That works. 1 and 4. Green is done. White is done. We've just got blue to do, and now we get a 1 there. That's a 1, 3 pair. That's a 2, 4 pair. Oh, is this obvious? If that was a 2, that would be a 1, and this would be a 3. If that's a 3, this is where 2 is, and this is where 4 is. It can't be 1, 2, 3, because that can't be 4. So 4 has to be on these. Right, so there we go. That is I think the only tricky bit really of this, apart from just seeing the grids as one entity. And I think that is the solution. Stopping the clock at 3 minutes 20 seconds. If I press tick here, it'll hate it. And it does. So we'll undo that. But I think that is the right solution. I mean, it's a clever lot of overlaps, but really there's nothing tricky once you start considering the between lines and the arrows. Here's a little tip for anybody who wants to give their young children a start in Sudoku. If you do a 2x2 grid, all you have to do to create a working Sudoku puzzle is to fill in a 1, a 2, a 3 and a 4 so that they occupy each of the rows and columns of the puzzle. And it must always be a solvable Sudoku. Let me see if there is an example here. So that you would have 1, 1 in... I'm not sure that there is actually. It's certainly not the only way to make these grids. That's annoying. I would love to show you. But if you put in a 1 there, a 2 there, a 3 there, and a 4 there, so that one of each of the numbers is in each row, column and box, it will always be a solvable and relatively easy Sudoku. So for very young children, you could even add 1 more given number, and it would, which you can work out, and it would definitely be a very, very approachable Sudoku. Now I can't see examples here of where those patterns actually exist. I mean, there may be some, and I'm just missing them. But there we go. No, I can't. But anyway, let us move on to slot machine. Yeah, I'm not necessarily expecting this to be the easiest. Okay, let's get cracking. We've got these sort of rotating drums. How do we start? 1, 2, 3. I want to replicate this 1, 2, and 3 somewhere. That could be 1, then 2, then 3. Or 1 is going to be in one of those cells. And it can't be because all of those, well, yes, all of those would push 2 or 3 into this box where it can't be. So 1 is up here with 2 and 3. Now in this box, 1 is going to have to be in one of those positions, but 2 and 3 can't end up there. So 1 can't be in either of these or that. 1 is in one of those two. 2 is in one of those two. 3 is in one of those two, and we know that that must be 3. Wow, okay, that's quite a neat start, actually. So those are the 1, 2, 3s. We know the exact dispositions. 4, 9. So in between the 1 and the 2 is a 4 or a 9. Well, we can see here it's a 4. So we can fill that all in. Then in between the 2 and the 3 is what? 5, 8, or 7. And it's 5 from this one. So we can fill that in all cases. Now we've got 6, 7, 8, 9 to put up here. 9 must be in one of the next two. And it's not in the next one after 3, so it's 2 down from 3. Then 6 can't be above the 9 in any place, actually. Maybe we'll come back to the rest, because it looks like that might stall there. 8, 9, 4, 1, 2, that's 6 or 7, 2, 9, 3. 4 is there in box 1. That is a naked single 6, and that is on the slot machine. So we can put the 6 in above the 1. Can we decide between 8 and 7? Not yet. Weird. Okay, that's a naked 5. Let's put in 2, 3 as a pair. This is a 2, 8, 9 triple. This is a 3, 5, 7 triple, in which we know the 5. So we get a 6 here. That doesn't fix the thing I'm still wondering about. That is a 7, 8 pair because they see 1 and 3. That's a 1, 3 pair in the corners. That's a naked 4. 9 and 6 to finish the middle row bits that I can do. That's a 2, 9 pair. 4, 7 down here. And that finally determines that 7 and 8 go above and below 9 respectively. That finishes the slot machine drums. 8 and 2 are done there now. And the 7 has resolved 3 and 7. That resolves 1 and 3. That fixes 2 and 3. 4, 7 pair, that can't be done there. 5 and 9 at the top can. Now 5 here, 8 and 1 to finish the column. I can do this 4, 7 pair now. Now I'm just in columns 4 and 6, looking for final pieces of the puzzle. So long as there's no mistakes, we're going to finish it off now with a 4 and a 2. There we go. Time 3 minutes 43 seconds. So again under 4 minutes. Those are pretty good times. I think on both puzzles I would be certainly expecting to get 2 hats for each of those. Maybe I'll have to wait till Philip Newman. It's nice to be back with the traditional setters, so I sort of feel I have some idea what to expect. Right, thermo from Sam. Let's restart this one. What do we get here? Right. Does that have to be 4, 5, 6? Yes, it does, because this can't be 1 or 2 in the box. So that thermo is just basically given. In fact, I can do the 7 and 3 in row 2 as well, which the only thing's breaking up the orderly sequence there. Now, this can't be a 3. 5. It can't be a 5 either, because that would put 7 on the line. So 2 there. I think this has to be a 3. Yeah. 4, 5. Now we're up to 6 and 7. Oh, 6 and 7. And then this must be 9. Yes, again, that 8 is much more helpful than I'm allowing for. This is probably a 1. Yes, it can't be a 4 because we'd have to put 5 or 6 on the thermo. That's probably a 2. It definitely is. Just given everything it sees. That could be 3 or 4. This then can be 4 or 8, but it can't be 8 because we can't put a 9 here. 4, 5, 6, 7, 8 there. So that is the longer thermos done. Now we can do 8 and 1 in this row and 2 and 9 in this row. Up here. No. How about, yes, that's a 5 by Sudoku. That's a 6. That's a 4. That 4 is helpful. That can't be 9, so that... Oh, hang on, this has gone wrong. Ah! No, it hasn't gone wrong. It hasn't gone wrong. That could be 9. I'm reading this thermo the wrong way round, something I am occasionally disposed to do. So that's a 7-9 pair. Oh, in fact, that is a 7 because of this 9 up here. Wake up sometimes, honestly. 6, 5, 8. Can't do much else there. 4, 3, 2, 1. That's a 7, 8, 9 triple because they can't go in here where there's a 5, 6 pair. Now I can fill in 2, 3, 4, 6 there, and 1 and 5. That thermo didn't seem necessary for my solve of this puzzle. 5 or 6 here, so that's quite big. 6 or 8 next, then 8 or 9. 4 has to go here now. 1, 2, 7, 4, 3. That can't be 5, so 5 is there. This is 6 or 8. It can't be 8 because we can't put a 9 beneath it. So in fact we put an 8 there. That's going to finish box 1. 5, 6 pairs done. We are not going to get a time under 4 minutes this time, but never mind. 7, 5 pair there. That's a 6. 6, 4, 3, 5. We've got 8 and 9 to put in here. And 7 actually. Oh well, that has to be 8. Because it can't be 7. Then we've got 2, 1, 3, 4 and 6. Yeah, they're done. 1 and 2. 3 and 4 here are resolved. 1 and 7. Can't do them. This 7, 8, 9 triple is done. There we go. Now, down the column, 5 and 9, that sorts out 5 and 7. Now I can do 7 and 1 over here. Then come back to the middle box, 8 and 1, all 4 and 2 left again. There we go. Oh, just over 4 minutes, 2 seconds over 4 minutes. So pretty quick again. I mean, it's just possible the cut-off time to reduce to 1 hat was 4 minutes, but I doubt it. I'd be confident about that. So, brings me on to Philip, who often takes me longer than the others. So the squares are even numbers. Let's go. Well, that's quite a lot of squares. There's 4 in every box in which they appear. So they're all the even numbers. In those boxes, all the evens are marked. So that's got to be odd. That's where 5 must go. 9's in one of those cells. I don't really know what order to approach this in. That's a 2, 4, 8 triple. So 2, 4, 8. That's a 2, 6 pair. I can put the 2 in. That's a 4 and then a 6, 8 pair. That is 4 or 8. That's not so helpful. That's 4, 6, 8. So that's a 2. 4 and 8 here are resolved thanks to the givens. Now that's a 2, 6, 4, so we get an 8 there. Actually, we can do the 2, 6, 4. That's a 2, 6 pair. They're done. That's a 4. So I'm doing the evens first, it turns out. I was sort of clearly experimenting with not doing it that way around, and it wasn't working. That's an 8. That fixes 4 and 6. This 6 and 8 are resolved from the bottom of the grid. 8 and 4 from the left of the grid. Yeah, the given helps do these. 6, 4, 8, and that does 2 and 4. And that's, Oh, and I've still got a 2 and 8 to put in the central box. 2 must be there, and 8 must be there. Now I can just do everything else as the odd numbers. So we've done 5, 3 there, 7 in this row, and a 1, 9 pair in the central box. That's a 3 with a 1, 9 pair on either side. That's where 3 goes in box 6. These are from 1, 5, 9. That must be where 7 is in box 2. That's a 1, 9 pair, so this is a 5. There is a 9 in one of those cells. I've seen that before and it doesn't help. 3 in one of those two, don't know. 9, no. 3 in one of those two. Getting a little stuck here. That's 1, 5 or 9. I don't know which of these is a 3. That must be, I don't know. They're from 1, 3 or 9 as well. 1 has to be in one of those positions. 5 has to be in one of those two. So 5 in column 3 is there. Now that is helpful. Would have been good to see that before. That puts 7 in column 8 there. This is a 7, 9 pair, which means this is from 1 or 5. 5, 6, 2, 8. So 1, 7 and 9. 1 is in one of those two. Yeah, Philip is just good at sorting me out here. 9 there, 7 and 1 to place, which I can't do yet. That's also 1 or 7 now. 3 and 1 in this column. Oh, this is the last one in its column. It's a 5. That's 1 or 3. It's just not coming. 1 or 3. 5 in the bottom row. There it is. 7 or 9. 3 or 9. Come on. Something disambiguates all these. That's not a 5. What about this then? Last cell I haven't pencil marked. 1, 3 or 5. So what resolves all of these remaining cells? 3 is looking at that from all the way up at the top where I couldn't see it. Right. Irritating. Scanning like a stormtrooper, as it is proverbially said. Right, we get a 1 there. 1, 5, 9, 1, 9. I'm not going to get the 4 minutes, of course, because it's Philip, but I am going to get under 5. There we go. 4 minutes, 25 seconds. I mean, when I first noticed that there were 4 evens in every box, I really thought, after all, this was going to be a walk in the park. But it's not. Philip's always got something up his sleeve, and it wasn't that straightforward, even when it was just down to the odds. Anyway, that brings us on to Clover's arrow quads. And yeah, obviously these double pairs being around is going to matter. Let's have a go at this. Let's get cracking. Oh, look, this arrow is useful. The 1s have to be separated, have to be diagonally opposite. So that must be a 2 and a 3. The 7s, obviously, again, the 5s can't be on the arrow. Now they can't have a 1 or a 5 in, so they're a 3, 4 pair. Oh, the 4s could be on the arrow. The 9s can't be. I don't know if I know enough about those. The 2s could be. Otherwise, it's 1 and 3 on the arrow, so I don't really dare to put that in. Now, 6 arrow is 2 and 4 if it can't have a 1. That gives us a 2, 3, 4 triple. 5. And that can't be 7. It's 6, 8 or 9, but it can't be 6 because that can't be smaller. So if it's a 9, this is an 8. If it's an 8, this is a 6. Leaving 2 or 1 at the top of the arrow. There is an 8 there. Oh, there's a 9 here. So that's a 6, 7 pair. That's an 8, 9 pair. This 8 arrow doesn't have a 5 or a 6, so it's 7, 1. There we go. This 6 arrow now is 2, 4. Got 3, 5 and 8 down here. Surely that can't be 8. No, so 8 is fixed on that. This can't be 3, 5 because of that cell. And it can't be 7, 1 because there must be a 7 there. So it's a 2, 6 arrow. That's a 2, 3, 4 triple. So this is 5 or 9. 9 must be in one of these cells because it can't be on the arrow. What about this? It can't be 2, 3, 4, 6, 8, 1 or 9. That's 5 or 7. So this is 4 or 2. And again, we've got a 2, 3, 4 triple. 1, 9. This is a naked single 8, weirdly. 7 must be down here. So this is 6. That's a 7, 5 pair. Oh, I've got a 2, 6 pair, and I left 2 in there as a possibility. Just not very alive. Right, that's got to be a 1 now. It can't be a 2. So the 2s are not on the arrow there. That's become a 4. All our 2, 3, 4 pairs are now suddenly resolved, including this one, if I just work out how. There we go. Now there is a 9 there, so there isn't one here. That should be obvious again. Right, there is a 9. Oh no, 8, 6 must be down here. So again we get 8, 6, 2 on the arrow. That's a 1, 9 pair. 8, 6, 4, 2. 9, 7, 1, 2. Right, we can fill in 6, 4 and 3 in this box. And of course the 9, 8 pair. Now we can do 5 and 3. 2, 6. That's where 3 goes in the first column. Then we've got 1, 4, 9 at the top. I can do the 9, but not the others. That's a 2 on the arrow. All of these corner box arrows are 8, 6, 2s. That's very weird. Nice patterning, Clover. Very clever. 5 there. We've got the 6, 2. Got a 1 and a 7. 1, 9. Central column, that's an 8. Then we can surely do 5 and 3 in some way we can. That gets 5 and 7 done. 7, it has to be on the arrows, on the quad. 7 and 6 are done there for 8 and 4. 7 and 9 up here. Yes, there is a given 7 that sorts them out. 1 and 4, just one pair left to do. They must include a 4 and apparently a 3. And there we go. So another 4 minutes 19 times. So all under 5 minutes today. That's extraordinary. So that was under 4 minutes. So was the second puzzle. And then we went over 4 minutes, but less than 4.5 minutes for all the others. So a very quick set of gas today. There was once before when I wondered if the gas puzzles were easier because the constructors were a bit embarrassed about having put some harder ones in the week before, and it turned out that was roughly true. I wonder if they were thinking, oh well, the crossover setters have given us some tough puzzles, so we'll really come up with some easier ones now. I doubt it very much. Maybe I was just on form today, but I suspect you'll have done okay at those puzzles. It'll be very interesting reviewing the times in the comments, because they're always a very good guide to how difficult the puzzles are. But that was great fun. Lovely to do another gas video as always, and they always seem very popular, so I'm very pleased about that. We'll keep doing them, that is the plan, and hope to see you soon on the channel for other Sudoku. Bye for now.